Hi everyone, I'm going to go over question number 1 from the chapter 6 bingo questions. Now this question deals with a book that's on a table and you've given this book a push of 2.4 newtons. It travels 1.5 meters on that table, and then the force of friction is also given, which is 0.6 newtons. So I've already drawn a free body diagram that helps us see what's going on here. So we can see that the forces acting upon the book are the normal force pointing up, the force of gravity down, the force of friction, which is opposite of the force of the push. So part A of the question wants to know the work that is done on the book from that 2.4 Newton push. So what we need to do is use this equation with cosine theta. So now theta in this is just 0 degrees because it's a horizontal push is what it says in the problem. And so since we know that cosine of 0 equals 1, then really that just becomes 1. And since we know all of these variables other than the work, we can just plug in the values we know and solve for part A. So we'll just say work subscript A equals the force, which is the 2.40 newtons, times the displacement, which we know is 1.5 meters. And we know, like I said, that cosine of 0 degrees is just 1. When we throw that into the calculator, we end up with 3.6 joules. So the work that's being done when that push is given is 3.6 joules. Now, there are 5 parts to this question, so I'm going to erase this work, but I'll keep the answer because we're going to need to go back to that in one of the upcoming parts. Okay. So now with part B, it wants to know how much work is done on the book from the friction force. So we know that the friction force was 0.6 newtons, and the theta is, so we'll write out the equation again. So the angle this time is 180 because the force, if it's moving this way, the friction is the opposite way, so it's 180 degrees. So now when we plug everything in, and this force is that force of friction, so we know that the work in B equals that 0.600 newtons times the 1.5 meters times cosine of 180 is -1. So when we plug this into our calculator, we end up with the work is equal to -0.9 joules. So we'll put this up here with our other answer. And it makes sense that that's negative because it's being done in the opposite direction. So in our body diagram, if I label it, that makes sense because that friction is doing work in that opposite direction. So it makes sense that it's negative. So now for part C, it wants to know the work that's being done by the normal force onto the book. So once again, so it's WC equals the force of normal force cosine, and this is going to be 90 degrees from, because of where the normal force is. We know that cosine of 90 equals 0. Since this is all multiplication, it's going to equal 0. Which makes sense, because any force that's being done perpendicularly, we know that when, you know, the answer to a dot product when things are perpendicular is 0, which makes sense because you can't do work if it's not, you know, moving in that direction. So the work that's done by the normal force is just 0. So now part D is the work from gravity, and so and it's going to be 270 degrees, which the cosine of 270 is 0. So just like with the normal force, it's going to equal 0. So now we've found all of the work from all of the different forces that are acting upon this book. And in part E, what it wants is it wants the net work. So the way we do that was we just add up all of these. That's why I kept them all up on the board right here. And when we add these up, we end up with 2.7 joules. So work net equals 2.7 joules. So, like I said, you just add all that up. Since that's negative 0.9, you know, subtract that from 3.6, the others are 0, you end up with 2.7. So, hope you learned something and hope you enjoyed watching this, and we'll see you in the next video. Thanks.